Hello, everyone. I'd like to welcome you all to Hydrocarbon Processing's Executive Series. So, in this enhanced video platform, we speak with the technological innovators, operators, and suppliers that are optimizing the global hydrocarbon processing industry. Now, this series is going to feature the thoughts and opinions of top executives and how they see trends and challenges that are facing the hydrocarbon processing industry, market shifts affecting production and operations, supply and demand fundamentals, novel technologies that are shaping the refining and petrochemical processing industries, and so much more. So, on today's episode, we have a very special guest joining us from Honeywell UOP, Keith Couch, who's the Senior Director, Business Development and Integrated Projects. So, we really want to welcome him in. Keith, how are you doing today?
Thanks for having me, Lee. I appreciate it. Appreciate the time to talk today.
Excellent. So, before we dive into the conversation today, could you let the viewers know a little bit more about Honeywell UOP and, of course, your role with the organization?
Sure. Honeywell UOP has been in business originally as Universal Oil Products, founded in the Chicagoland area in 1914. So we've been in business for 110 years. We started off with the Dubs thermal cracking process, which was really the birthplace of oil refining, at least the conversion of oil into lighter, more valuable products. From there, we've grown out to a portfolio that covers almost every technology in a refinery and also into petrochemical base stocks. So benzene, toluene, xylene, propylene, ethylbenzene, styrene monomer. And one of the things that we're going to be talking today is how is UOP approaching the adjacencies for ethylene? How do we help producers and steam cracker technology providers provide lower carbon, lower cost, and more reliable steam cracker technology for on-purpose ethylene production?
And how about your role with the company?
So I run our business development function for UOP overall, a global role. So I have offices or personnel in US, UK, Saudi Arabia, India. So really geographically positioned in all of the major growth areas in the world.
And so now I kind of want to get into the meat of, I guess, this conversation. And so right now, with your global outlook, what are some of the biggest challenges that you see that are facing the refining and petrochemical industry today?
Yeah, one of the biggest challenges is coming up with the cash available to invest. And when we look at the projects, everybody wants that economy of scale. Everybody wants to grow into what truly is world scale, drive economy of scale. And when we do that on crude to chemicals, it can rack up a pretty big price tag. We have to be smarter about how we deploy capital. And in addition to the capital deployed, we also have to be a lot different in our mindset on carbon intensity. Lenders are very, very focused on how much cash they put out into, whether it be fossil or renewable or bio. They're still very conscious of the amount of cash going in and what's the carbon footprint associated with that cash, associated with that investment. So we're starting to really see, while we've been talking about decarbonization and CO2 footprint for a while, we're really starting to see owner operators truly invest in driving it down. And a lot of that's being driven out of the financing industry, requiring those lower levels, requiring best in class in the world before they're going to turn loose the cash to help customers develop those projects. Fundamentally, that's the biggest challenge we face. We get a lot of oil refining operators who are so comfortable in refining that they haven't moved into petrochemicals. And they're very slow to do so. A lot of those opportunities are being taken up east of Suez. When we look at where the Middle East is starting to invest, Asia, China, Southeast Asia, a lot of investments going in to produce fuels in country, in region, financed against the import price parity of products that used to come out of the US or products that used to come out of other places. When they get to 200,000 barrels a day of refined fuel capacity, then we're starting to see those projects move forward. First for the fuels, and then articulating or integrating with petrochemicals for a higher quality of debt service. Fundamentally, crude to chemicals, driven by the fact that there's not enough merchant feedstocks to fill or supply the growing petrochemical demand. When the Koreans did paraxylene investments up to and around 2012, that was pretty much the end of available heavy naphtha on the market. That's when we started seeing China move from importing heavy naphtha intermediate feedstocks to make PX to go into PTA, PET. That's when crude to chemicals really started to take off. Now we're in a situation where olefins, it's growing 4 times faster than BTX. So now we're in a situation where there's an all-out wave of interest in steam cracking, fundamentally making ethylene, and PDH, fundamentally making propylene. Those contain derivatives feeding into much of the supply chains, building out most of Asia.
Excellent. And now, one thing that I know that you've mentioned, of course, is profitability. So I'm kind of curious then is as all these different types of operators then now transition and they focus on things like improving sustainability, they also, of course, have to remain profitable. So how do you do that? How do you invest in sustainability and also not even just remain or even become profitable, but just stay, profitable in the future?
Yeah, fundamentally, you have to come up with an IRR positive investment, right? And everybody wants it higher than their hurdle rate. And I think that's one of the things that scares off a lot of refiners. They've traditionally had a mindset of, we're going to invest on things that are 35% IRR and higher. Petrochemicals, a lot of value, but they're big, expensive units traditionally. So we're seeing a lot of people have to repeg what they're expecting on an internal rate of return for their petrochemical products when you start talking about crude to chemicals. A lot of that value comes into what do you do with those derivatives? How do you get into the textiles, the fabrics, the bottles, the shirts? And that's where a lot of the Chinese firms that are so integrated, they were textile producers or they were clothing manufacturers who continued to back integrate along the way. Right? As a refiner who simply wants to put out petrochemical base stocks, it can be a little tougher. Fully integrating into that downstream or finding a partner who's integrated into that downstream is really key to strategic success of these projects. And the value is coming from the derivatives, what you do with that end use, not just making the ethylene or the propylene. When we look at a lot of the successes have to come with economy of scale. And again, the biggest trade-off we have on economy of scale is the price tag associated with it. How are you going to pay for it? Internal rates of return is fundamentally how that financing industry is going to look at it. We have to do more with less. So one of the big focuses that we've had over the last couple of years when we talk about being more efficient is how do we do process intensification? How do we get rid of a lot of the steel, a lot of the utilities, and a lot of the emissions that come with it? How do we be smarter on energy intensity? In the last 10 years alone, we've taken over 30% of the capital cost out and about 40% of the energy out of a PX complex. Out of propane dehydro, we've had almost the same magnitude of improvements. So we're in a position where even with an oversold base, even with an oversupplied market, we're able to have new technology come in and pretty much obsolete the older, less efficient assets. That's really, really striking in the PDH world because that really didn't even take off until the 2013s and 14s. A few units before that, but not many. We're already seeing that investment, that renewal. As licensors and technology people, we have to drive that. We have to try to obsolete the old. We have to drive more efficiencies. We try to do it where you can revamp old assets. And a lot of what we're talking about today, it's not really possible because of those economies of scale are so large. Again, with paraxylene, we're talking about 2 million tons per annum in a single train. Steam crackers are now, if you're an ethane cracker, you're 2.2 million tons in a single train. When you look at some of the older assets and much, much smaller assets, one new unit starting up is putting 4 or 5 out of business. And they're able to do that, service their debt, and still clear 15 to 20% hurdle rates on a petrochemical project before we ever get into those detailed derivatives.
Yeah, and it's incredible that you can take that kind of, I guess, capital investment out of those units because those PDH units, PX units can be very, very expensive to build. And so it kind of goes then and segues on my next question is about, what are some of those technological advancements that enables you to do that? Do you have any examples that you can put forth to the audience?
Sure. One of the things that's really taken off for us is organic ranking cycle, a great way of recovering low-grade heat. Fundamentally, we have a tremendous amount of energy in aromatics complexes and steam cracker complexes and reforming complexes. We've traditionally blown that off to air. When you fundamentally decide on with that greenfield build or that new unit build, when you decide what your energy and CO2 footprint strategy is going to be, you're kind of locked in. I can help you improve it. I can help you update it, but those updates and improvements come as a marginal percentage of what we can do from new. There's lots of things to do with those. How we handle things like our cat max internals on reforming units, we're able to get a lot more capacity out of an existing asset. How do we get the hydrogen out of fuel gas? A lot better on recovery systems. Packing inside of columns. If you're an FCC operator and you haven't packed your main fractionator, do so. I have a lot of people tell me they haven't done things like that because they can't fit it in within the scope of a turnaround. Fine. Pack half of it this turnaround, pack the other half of it the next turnaround. Catalyst systems. When we start applying our catalyst reload philosophy in an ESG or a decarbonization mindset, we suddenly think differently about when should we reload? How do we handle activity maintenance versus and life of catalysts? A reforming unit's a great example. There's 26 major things that I affect inside of an operating refinery simply through a catalyst reload. Only 6 or 7 of those are actually inside the battery limits of the actual reforming unit itself. The others, those are in the rest of the complex. We have to think differently about the complex. We have to think about the overall site-wide or enterprise-wide impacts of what we're doing. We could do a lot through other mechanical revamps that could take a long list to go through. But the reality is when I build a new unit, I'm able to take advantage of all that and deploy the most efficient cash in one lump sum. So when we look at new technologies, naphtha to ethane and propane, a great opportunity for taking new technology and leveraging it for a fundamental need. We started seeing liquid crackers become the wave of what everybody was talking about for crude to chemicals. And we kind of scratched our head and said, well, everybody knows that an ethane cracker is the most efficient. You look at a cost of production chart, ethane is king. So why would anybody put anything other than an ethane cracker in? And the fundamental paradigm was you're going to use the feedstock that you have available to you. Especially if you're an NOC, you're going to use the feedstock that you have. We start seeing crude to chemicals in the Middle East, they're liquid crackers, and you think, my goodness, why is that true? And you realize that the world is starting to run out of ethane. It's co-produced. Ethane and propane both co-produced from oil and gas exploration. You don't drill an ethane well, you take what you get. And what we're seeing globally is the amount of ethane isn't keeping up with the demand growth in ethylene products. We see the Middle East running out of ethane, except for Qatar. Places like Saudi, places like Kuwait, on-purpose ethane, all of a sudden becomes something that could provide a lot of opportunities. And that's truly where they have light naphtha. Why don't we convert that naphtha into the feedstock that's most efficiently converted? We tried for years to go directly from naphtha to olefins. And in that, we always made too much dry gas. We always made too much methane. The catalyst cooked over too fast. The activity wasn't there. The stability wasn't there. And suddenly you realize, let's not just do it all in one. Let's leverage a steam cracker for what a steam cracker does really, really well, which is convert ethane into ethylene. Now we got to figure out how to convert all that crude oil the most efficiently into the ethane feedstock that the steam cracker wants and the propane feedstock that a PDH unit wants. When we realize that, suddenly the amount of steel, the amount of capital, the amount of energy, the amount of carbon intensity for that whole crude to chemicals complex reduces by about 50%. All of a sudden, when we realize, stop trying to make fuels into petchems, stop forcing feedstocks that don't want to be petchems to those petchem products, we're able to reduce the crude consumption per ton of olefin by about 50%. It's transformative in how we're thinking about linking technologies together, and it's changing the landscape of how we think about feedstock merchant traffic across the world. It's changing where we think about our investments. When you look at the U.S. Gulf Coast, has plenty of ethane still to move around the world. The problem is in the supply chain and the logistics. Do I want to become a merchant trader? Do I want to put $8-9 billion into shipping to move that ethane around the world? Or do I want to put that $8-9 billion to work for me on site as an asset that's actually converting feedstocks into products? And that's a conversation we're having a lot in China right now. One of my coworkers, Greg Funk, has been spending about 50% of his time in China. Again, with an installed base that's feeling the pressures of feedstock access, trying to make their systems more flexible, trying to make sure that they have access to feedstocks to continue to drive the growing demand of petrochemicals in Asia.
No, it's definitely very interesting stuff. And so kind of one of the last things I wanted to go over was this naphtha to ethane and propane technology that UOP makes. So can you, for people that might not be familiar with this technology, which I think y'all everything needs an acronym, so NEP. So can you tell the viewers a little bit more about the NEP technology, maybe some of the features, benefits it has for producers of petrochemicals?
Absolutely. So fundamentally, great marketing in place. What does it do? It converts naphtha to ethane and propane. We probably should be a little bit better on our marketing side with that, but hey, it works. We're calling it NEP because that's exactly what it does. We're going to take that light naphtha, and to stretch out that definition of light naphtha, think LPG through C7s, right? And we're going to take that, put it into a fixed bed reactor system. It looks pretty much just like a semi-regen platforming unit from the 1950s. Gas phase, downflow, dumb steel, carbon steel. Doesn't have to be high metallurgy. Not a lot of chemicals. There's no chemical additions for sulfiding or chloriding. It's a pretty basic reaction structure. Well practiced again for over 70 years. We take naphtha from anywhere you have it, whether it be straight run naphtha, FCC naphtha, coker naphtha, or hydrocracker. And in new complexes, really going to be driven by a hydrocracker. When we marry that concept of crude to chemicals, that hydrocracker now becomes key. We're no longer thinking about the 80s where we made naphtha from hydrocrackers, and since then we made diesel. Now we're going to redefine hydrocrackers of the future by what's their C6 minus conversion. When we take crude oil to chemicals, it really is about getting to that C6 minus material the most efficiently as possible. The paradigm in the past has always been you increase the operating severity on your hydrocracker, you make more ISOs and fewer normals. Steam crackers don't like ISOs, right? So there's a peak you go through somewhere around 70 to 75% conversion on a hydrocracker that the traditional steam cracker paradigm would say, don't go beyond because my yields are going to decline with those high ISOs. NEP doesn't care about the ISOs. We call it isotolerant. The amount of difference between the ISOs and the normals processing in NEP is negligible. We could show it on paper, but it truly is small, and it really doesn't impact the economics of the NEP process that much at all. So fundamentally getting to that wide brand, we can even produce, instead of just propane and ethane in NEP, we also have a variant that comes out with 100% net ethane production, right, with no propane at all. So if you don't want to be in the propylene markets, if you don't want to be in the propane markets, ethane, truly for you, we can drive that solution as well. What's it really doing? It's allowing people who have traditionally been really high on the cost of production curve with naphtha feedstocks, especially in Asia, Middle Asia, Europe. It's able to garner those naphtha feedstocks that were really high cost of production ethylene, and move them down the cost of production curve. Not quite as good as putting an asset on the U.S. Gulf Coast, but then the U.S. Gulf Coast has the opposite problem of taking those products and moving to the markets in Asia. So it's truly allowing customers much greater feedstock security and access where they've been constrained in other parts of the world. It allows them to defer that ethane shipping cost, that ethane logistics and handling cost, and really helps them have control of their domain. Moving forward on where do they want that ethane to propane split to be? What's that ratio? They can move across operations, chasing after the ethylene markets or chasing after the propylene markets, and not being tied to really expensive merchant feedstock supplies.
Excellent. So one last thing before we let you go is it's an easier question for you. Is if the viewers leave this and they want to find out more information, let's say about NEEP or UOP in general, where is the best place that they can go to?
Two fundamental places. They can reach out to HoneywellUOP.com, and that'll take them to the UOP portion of Honeywell. We're included in the Energy and Sustainability Solutions group within Honeywell's portfolio of businesses. As an alternative, reach out to me on LinkedIn. My profile can be found very easily under Keith A. Couch, or email me directly at keith.couch@honeywell.com.
Excellent. Well, Keith, again, really want to thank you for your time today as you just sit down and discuss some of these important issues that are facing, the global refining and petrochemical industry. So again, really want to appreciate and know how busy you are. So thanks you for giving us a couple of minutes of your time. And then lastly, of course, we really want to thank all of you for viewing this latest installment of Hydrocarbon Processing's Executive Series.